Good morning, good afternoon, good evening, everyone. I wish to thank the organizers and the sponsors, Squared Up, Cookdown, OpsLogic, Silex, NICE, Gridmatics, Topcore, and Exterior Consulting for once again inviting me to give a presentation in this awesome global virtual event for the 5th year since 2020. The topic I'm presenting is entitled Orchestrating Insightful Plugins in Copilot for Security with SCOM. Here's a little bit about me. My name is Wei Hao Lim. You can call me Wei. I'm a Microsoft Principal Cybersecurity Cloud Solution Architect based in Melbourne, Australia. I specialize in multi-cloud monitoring, security and AI solutions, threat detections, data visualization and automation design, primarily leveraging Microsoft Copilot for Security, Microsoft Defender for Cloud, Microsoft Sentinel, SCOM, Azure Monitor, and Azure Cost Management. I work mainly with enterprise customers to implement and demonstrate the value of Microsoft's security and AI services, monitoring solutions, and help remove technical blockers, drive success, customer confidence, usage, and consumption of our products and services to help make our customers more secure. And as mentioned earlier, this is my 5th year presenting at SCOMathon, and it is such an honor to be here again today to speak to you all on this topic that I am very passionate about, and a generative AI security product that I am heavily involved in this year, which is Copilot for Security. The objective of this session is to discuss on the idea and the advantages of leveraging and integrating your internally built knowledge and intellectual properties for monitoring, management, and security in your SCOM environments with a generative AI security solution like Copilot for Security. Then I will demonstrate an approach that builds on environment-specific monitoring data in SCOM to create effective and insightful plugins in Copilot for Security and how it can provide further value to security incident investigation, from enrichment, impact analysis, and security reporting. Here is the agenda for today's session. The agenda is organized under the following topics. We will first look at the challenges in cybersecurity today, followed by an overview of Copilot for Security, what challenges this solution can help solve, its data flow and accessibility. We will talk about the extensible and customizable capabilities of Copilot, mainly in plugins and skills. Next, I will share a bit of my experience in the field on how our customers today are leveraging SCOM to monitor their hybrid cloud ecosystems, and that there is an opportunity to further extend Copilot for Security with SCOM as a source it can leverage to provide further value to its different use cases. Then I will demonstrate how we can leverage a custom plugin for SCOM in an incident investigation with Copilot for Security to help provide further value and enrichment to the incident investigation use case. And finally, I will go into detail on the approach that I have developed to create a custom Copilot for Security plugin for SCOM and the steps I took to build a proof of concept to showcase how the plugin can be utilized in an incident investigation session with Copilot. For this session, it would be great to have some knowledge of the SCOM architecture, core components, and data flow. Knowledge of basic authoring, workflows, and targeting in SCOM, like what are rules, monitors, alerts, discoveries, and health states, and also some familiarity with navigating the SCOM operations console. PowerShell with SCOM commandlets, Azure Monitor logs, or Sentinel and KQL queries will also be used and covered in this session. So it will be great to have some experience or knowledge on these areas as well. So cybersecurity is a defining challenge of our times. The sheer numbers are staggering as shown on this slide. The number of password attacks Microsoft detects has more than tripled in the last 12 months, from about 1,300 per second to more than 4,000 per second. And the median time for an attacker to access your private data if you fall victim to a phishing email is now only 72 minutes. Defenders are simply outmatched. Attackers have more resources and don't have to play by the same rules. Security tools have sprawled and become more difficult to manage, often resulting in complex architectures and disparate views across an organization. Posture and configurations shift and drift, while attackers increase the number, scope, and sophistication of their techniques daily. Add to the global shortage of skilled cybersecurity professionals, and it's no wonder that security incidents have become an everyday occurrence. So, security professionals are up to huge challenges, a challenge that we believe we can help solve with Copilot for Security. Let's start first with an overview of Microsoft Copilot for Security. Copilot for Security is a generative AI security product that helps defend organizations at the speed and scale of AI and helps increase the efficiency and capabilities of defenders to improve security outcomes while remaining compliant to responsible AI principles. With Copilot for Security, security analysts can move faster, so a shorter time to response and remediation, and more time to focus on high-value tasks. It provides a natural language, assistive Copilot experience that helps support security professionals in end-to-end scenarios, such as incident response, threat hunting, script analysis, security reporting, and posture management. Copilot for Security combines the most advanced GPT-4 model from OpenAI with Microsoft hyperscale infrastructure, a skill orchestrator trained on security, plugins, prompt books, including organization-specific information, authoritative sources, and global threat intelligence. Therefore, it is much more than just a large language model behind the scenes. The diagram on this slide shows the data flow of Copilot for Security. This diagram is referenced from the Microsoft Learn website. It shows that Copilot for Security's capabilities can be accessed from the standalone experience as well as embedded experiences available in other Microsoft security products. The blue dashed box shows all the components operating inside of Microsoft Security Trust boundary, and the numbers in the data flow diagram show the various pre-processing, processing, and post-processing steps to get the formatted response to the user. So once the prompt or input from the user is sent to Copilot, it determines which plugins to leverage during pre-processing. Then it sends the modified prompt to the large language model and receives a response on a plan to fulfill the user's request. Copilot for Security then accesses the plugins to gather information and to take action for post-processing. Then it performs responsible AI checks on the response, where it checks that the response is appropriate or not malicious. And after a final validation with the plugins, the prompt response is given back to the user prompt in a standalone experience or within the embedded experience of these Microsoft security products. Copilot for Security is intuitive, customizable, extensible, while supporting responsible use of generative AI. It meets users where their daily workflows exist and natively integrates with existing tools through the standalone and embedded experiences in other Microsoft security products. So double-clicking into the customizable and extensible side of Copilot for Security, today, capabilities like custom plugins, custom prompt books, logic app connectors, and knowledge-based integration empower users and the teams they collaborate with to use Copilot together with their organization's existing processes, tools, templates, and workflows to accomplish their daily tasks. And for this session, we will be focusing specifically on custom plugins and how to utilize it to bring in internal knowledge from your own security ecosystem to further extend the functionality and enrich the prompt experience in Copilot for Security. So what are plugins? Plugins are additions to large language models or LLMs to enable advanced and custom functionality. It allows you to extend Copilot for Security into your workflows and experiences. You can connect to your business data sources, internal knowledge, keep data and applications where they are, and build your knowledge into the system with enriched information that is grounded within the context of your organization. How can someone in Copilot for Security leverage plugins? Copilot for Security comes with many pre-installed plugins from first and third-party applications and services. Pre-installed plugins are available out of the box and allow Copilot to source information when responding to your prompts. Custom plugins, which is what we will be focusing on in this session, extends Copilot's capabilities by integrating with third-party solutions or adding custom functionalities. You can invoke skills within plugins using natural language or direct skill invocation through the prompt bar in the Copilot for Security standalone experience. Enabling plugins is done by a global admin or security admin. Copilot for Security uses on behalf of authentication flow or OBO to provide access to other Microsoft services that your organization already have access to. The product has the same permissions of the user using it. So there's no situation where the product has a broader set of permissions than the user interacting with it. This means that the user can only receive responses containing data that they would normally have access to through the native tools providing the data. And you can build your own custom plugins, API, GPT, or KQL to perform specialized tasks or enrich your investigations. And the type of custom plugin that we will be exploring in our demo later to bring in environment-specific monitoring data from SCOM into Copilot for Security will be a KQL plugin. Plugins enable dynamic product experience for each user. Copilot users can switch on and off specific plugins that they want to be considered for the sessions they are creating to enrich their prompt experience. Therefore, everyone's Copilot experience could possibly be different in different environments. So let's circle back to the main objective of this session today. That is on the advantages and how we can further extend Copilot for Security with more enriched information by building on the internal knowledge, experience, and workflows for monitoring, management, and security detections that you have operationalized in your SCOM environment to get the maximum value from your Copilot for Security deployment. And how are we going to achieve that? By utilizing custom plugins in Copilot for Security, like we just touched on in the previous slides. Over the years, as SMEs or subject matter experts in the monitoring space, we have worked closely with large enterprise, small and medium-sized customers to help onboard and accelerate our multi-cloud monitoring solutions with SCOM and Azure Monitor to provide monitoring coverage for their hybrid cloud ecosystems. Many of our customers have large hybrid cloud consisting of an on-premise, Azure, and other cloud services setup, where SCOM is still deeply ingrained and heavily utilized in these environments and monitoring the availability, health, performance, connectivity, and security state of thousands of virtual machines, network devices, hardware devices, remote hosts, and critical distributed applications, with integration with third-party ticketing systems for alerting and dashboarding solutions. Many of these large SCOM management groups run thousands of detections and data collection workflows across their agent-managed servers or endpoints. These monitoring workflows are either defined in standard Microsoft management packs, like the Windows operating system management pack, the SQL management pack, or Active Directory Domain Services management pack, or defined in customized and proprietary management packs written internally or provided by third-party service providers. Many customers have a mature lifecycle internally in developing in-house custom monitoring or management packs that automatically discovers and monitors the critical components of their important applications. On the topic of security monitoring, I have seen quite a few SCOM environments with some form of customized security detections and assessments configured at distributed application level or monitored server level. An example would be a use case where the health availability and performance of the Arc antivirus and Azure Monitor agents are being monitored by SCOM to ensure continuous security coverage. And also, the flow and collection of security data into their cloud monitoring and security services is stable and consistent. So as you can see here, a mature, well-maintained and optimized SCOM environment will have tons of valuable monitoring information, detections, and insights that can be leveraged to help improve the overall health and security posture of a hybrid environment and help drive capacity planning, rapid detection of issues, and incident investigations. For environments with proprietary third-party or internally developed applications or workloads that could mostly be hosted or running on-premise, over the years, we have seen many organizations utilize SCOM to provide monitoring coverage to critical components of these applications, processes, and workloads through implementing ISV-developed management packs or through internally developed custom management packs. Developing these custom management packs would require internal knowledge, authoring skills, experience, and collaboration with developers and support teams in order to accurately identify these critical components to monitor and metrics to collect effectively. There are many good examples of these types of well-written management packs and monitoring solutions that have stood the test of time and still relevant to this day, running in SCOM management groups of many organizations of every size, in many industries and many parts of the world. This is why there's an opportunity here to further extend Copilot for security with all the internal knowledge, insights, and workflows from these types of SCOM environments as a source it can leverage to provide further value in use cases like security incident investigation, prompt enrichment, impact analysis, and security reporting. Another advantage of connecting Copilot for security to SCOM is that it can potentially help increase productivity thanks to Copilot's ability to simplify the complex. We all know that SCOM has a rather steep learning curve and it requires a lot of hands-on and long hours of understanding the different critical components and capabilities from administration to data types to infrastructure to authoring to operations and troubleshooting. This can be very challenging for junior or newly recruited analysts to learn how to operate or query SCOM for valuable information or its findings, and during an incident investigation or issue analysis in a short period of time. And in many organizations, security and monitoring tools have sprawled and become more difficult to manage, often resulting in even more complex architectures and disparate views across an organization, where in some environments, SCOM could be entangled in these problems as well. With Copilot for security connecting to SCOM as its source using custom plugins, analysts don't have to search through the operations console, run SQL queries or PowerShell scripts to query SCOM for the required information. They can simply ask questions in English or natural language, and Copilot for security understands the context based on the description defined in the custom plugin. And it sets the plan in motion and invokes the skill to retrieve the required information into the prompt experience of the Copilot for security portal. So this results in time saved, increased productivity, and unlocks new skills for perhaps more junior analysts or new hires. Let's walk through an incident investigation with Copilot for security and demonstrate how we can leverage a custom plugin for SCOM to help provide further value and enrichment to the incident investigation session. Note that in order for me to accelerate through the demo without the wait time required when prompting a large language model, I'm using screenshots instead. These are screenshots I took from the last time I tested my custom plugin in a Copilot for security workspace that is not publicly accessible. In this example, we will start the investigation in Microsoft Defender XDR. I will be using Copilot for security to perform a comprehensive incident investigation on a suspected brute force attack involving 2 devices in a role as a security analyst. We know that analyzing and understanding the events and information of Microsoft Defender incidents involves a lot of work and is a time-consuming task for security analysts. A lot of these security detections from Defender rely heavily on observability of the systems under management for security information collection. Aside from that, at the same time, there is also a wide set of customers using SCOM and Microsoft Defender in tandem. So let us see in this scenario how we can extend Copilot for Security with the richness of information and experience in SCOM to further improve and enhance the incident investigation experience. As a security analyst, I start my day inside of my company's endpoint solution, which is Microsoft Defender XDR. Copilot for Security is integrated in Microsoft Defender XDR. From the incident page of the suspected brute force attack incident, we can select the Copilot for Security button to get a summary of the incident and get the details such as the time and date of when the suspected attack started, the entity or asset that started the attack, the protocol used, and assets involved in the attack. Then, by selecting the Open in Copilot for Security button, I can extend the investigation using natural language prompts and more plugins by continuing the investigation in the standalone experience of Copilot for Security. I start my prompt session in the standalone experience with a natural language query, list the devices involved in incident 2411 from Defender. The response lists the DNS name of the devices involved with some additional properties. Copilot for Security offers a level of transparency with its process log by showing the user the plugin chosen as the response is being formed and how long it took. This helps to build trust in Copilot for Security and allows users to verify if it is delivering accurate and appropriate responses and empower the user to detect fabrications. In the process log shown on this slide, the incident analysis skill or capability of the Microsoft Defender XDR plugin was chosen as requested from the initial query prompt. We also see in the process log that the response has first been reviewed by Microsoft's responsible AI models for anything malicious or inappropriate before the response is presented to the user. Now it is time to pivot to another source to see if there are additional information about the two devices involved in the incident I'm investigating. To pivot to the custom Copilot plugin for SCOM for insights, I submitted a prompt in natural language and the Copilot orchestrator is able to choose the right custom plugin skill. Here, Copilot was able to recognize what these devices are based on the previous prompt response context in the same session and returns the latest security detection alerts triggered by SCOM from the target workspace for both of the devices in context, which is ZJump and ZDC. The response from Copilot also includes additional properties for each alerts like status, server roles, and when the alerts were created and updated. We see here that there are two alerts found for ZJump, one still open and one already closed. From the same response, we also see that there are 6 alerts found for ZDC, all are still open alerts. And based on the SCOM security detection alerts returned in the previous response, I add an additional query. What are the risks if multiple attempts were made to stop the connected machine agent on ZDC, as shown on this slide? Note that the connected machine agent is the Azure Arc agent. Here, we see in the process log that the generic capability is chosen. Therefore, the response to this prompt is generated based on OpenAI GPT-4 large language model, which is good at general knowledge and problem solving, as seen here in this example from the response provided. The highlighted sentences were additional information that includes details, explanations, and recommendations provided by the large language model based on its general knowledge on the Azure Arc agent. This capability is extremely helpful to security analysts to gain a better understanding of the risks implications of related security alerts while maintaining focus in the standalone experience and building context during an incident investigation. Pivoting again to the custom plugin for SCOM to return the threat scores, I use the prompt, get the most recent threat score for these two servers from SCOM. Again, Copilot was able to recognize what these two servers are based on the investigation context in the same session, and it returns the latest and highest threat scores for both of the devices in context, ZJump and ZDC. Now, here, I continue the investigation by asking which critical application do these two servers belong to, and tell me their roles in that application in the prompt. The highlighted sentences in the prompt response contains additional information on the session context and the responsibilities of different server roles. This shows us that the prompts in Copilot for Security are not executed in a vacuum, and Copilot for Security is able to continue to work through the same investigation, bringing along the same context from previous prompts or responses as the investigation evolves. Finally, to wrap up the incident investigation, I asked Copilot to write a report containing all the information in the context, summarize the findings from the investigation, and conclude with a set of recommendations as shown in this example. This capability helps save time for me as an analyst so that I can focus on more high-value tasks actually pertinent for securing the organization while keeping my other stakeholders in the loop instead of having to manually write up summary incident reports. Here, we see that this incident report provided by Copilot summarizes the entire session context of the incident investigation, enriched with valuable content from the custom plugin for SCOM, and categorized into 4 sections: incident details, investigation findings, server roles, and the name of the critical application involved, and provided a set of recommendations to improve the security posture of the affected devices, which can also be used to up-level skills for security analysts. The incident report can be further summarized to provide a non-technical executive level summary that can be shared with an company's leadership team. As highlighted on this slide, although the report generated is more brief than the full report and easier to understand, it still maintains the important points and findings enriched by the custom plugin for SCOM from the session context. And this concludes the end-to-end demo on how we can leverage custom plugins for SCOM to help provide further value in an incident investigation with Copilot for Security. Now, let's take a look under the hood on how this solution is built. Before delving deeper, here is an overview of the solution. The heart of this solution is SCOM and an Azure Log Analytics integration, through which environment-specific monitoring data generated from SCOM is available for Copilot for Security via plugins. Using KQL queries, we are able to build Copilot skills to gather information in context from the Log Analytics workspace. When these skills are added into Copilot as a plugin, the magic of the large language model makes contextual analysis possible. Copilot for Security is able to retain the context, merge the information from different sources, and present the end-to-end story effectively. I will now move on to the next section where I will be demonstrating an approach that I have used to create a custom Copilot for Security plugin. This plugin queries and retrieves environment-specific monitoring data generated from a SCOM environment to enrich the prompt experience in a prompting session within the Copilot portal. This integration approach is an extension from my previous work and research. Here's a quick recap to provide some context on it. So between 2017 and 2020, I have presented in a number of live and virtual events and conferences like SCOMathon on hybrid infrastructure monitoring related topics. Some of them would include demonstrating a repeatable approach that I have developed to extract important, relevant, aggregated, and monitoring data from well-tested management packs, like the Active Directory and SQL management packs, or custom management packs, like the ones written to monitor applications or critical processes, using an external integration way on the management server side for Azure Monitor Logs consumption. This approach starts by retrieving all the classes defined in a management pack or a group of related management packs of a specific monitor application, solution, or service using the get_scom class PowerShell commandlet. Then, for each class, information regarding each of its discovered instance or objects is retrieved. Information like the object name, path, current health state, alerts generated provide a high-level view of the discovered and monitored state of a specific application or service monitored by a SCOM environment. With each of these monitored instances, we can drill in deeper to find relevant performance counter collected for them and their values, if any, over the last few hours and calculate the hourly mean, max, and average as shown in this hierarchical view. Of course, alerts per monitored object can also be extracted with this approach. Once the aggregated data mentioned in the previous slide is extracted using a PowerShell script running on a regular interval, it can then be converted into JSON data and injected into an Azure Log Analytics workspace with the new Log Ingestion API or the Collector API that still works for now. The JSON payload can be sent from any systems or tasks via HTTP. Here is an example of how the records would look like and searchable with KQL in Azure Log Analytics. With this approach, environment-specific and critical monitoring data collected from different applications by SCOM agents distributed across the management group can be retrieved, aggregated, and then injected into an Azure Log Analytics workspace to be searched and analyzed. Here are examples of some of the potential use cases that can be covered with this integration. For example, provide a high-level view of the overall health and security state of critical applications with a hybrid or on-premise cloud infrastructure, and monitor availability and heartbeat of critical infrastructures, and correlate with data from other sources in the Log Analytics workspace with KQL to further provide insights on the health or security state of the hybrid environment, and then to trigger notifications with Azure Monitor alert rules when any scenarios matching these use cases return a failure result. So for the demo, I wrote a custom SCOM management pack in my test environment to simulate a SCOM monitoring and security detection solution for a critical application in my demo tenant called Contoso. The distributed application is hosted across 6 servers of different roles as seen in this state view. The management pack of this monitoring solution is written following authoring best practices with class definitions of different roles in the application. It also contains auto discoveries for these server roles and targeted security detection rules and monitors for specific class of servers hosting the Contoso critical application, as shown in this diagram view. This management pack allows simulation of security detections in the form of SCOM alerts generated by rules and monitors, and these alerts can be triggered on demand for testing purposes. Here is a list of some of the security detection rules added into this management pack. Multiple attempts were made to stop the connected machine agent, or an attempt was made to stop Windows Defender, or local administrators group was modified, like a scheduled task was created on the server, security event log was cleared, potential credential swap in progress, and so on. So this means that I can control which security detections are triggered on which monitored servers that are discovered as a role for the Control Critical application. And I added another feature in the management pack to calculate the threat score for each server based on the number of distinct detections by these rules and monitors found in each monitor server in the security, performance, availability, and configuration categories. I was able to include these security detection rules in my management pack for this demo, thanks to the inspiration I got from Nathan Gall's security monitoring management pack. This management pack contains more than 100 security detection rules, some targeted at domain controllers and some targeted at the Windows operating system level. You can go to his blog for more details and where you can download the latest version of this management pack. I then proceed to use the repeatable approach that I mentioned in the previous section to extract important, up-to-date, and aggregated monitoring data from all components of the Control Critical application monitored by the management pack and send it to a Microsoft Sentinel workspace for consumption on a 30-minute interval schedule. Here is what the data looks like in Sentinel or in Azure Log Analytics when a KQL query is used to get the most recent SCOM security-related detections for all hosts or servers. And when a KQL query is used to get the highest and most recent threat scores from SCOM for all hosts or servers. And with these KQL queries, I can start to build my custom multi-skill Copilot plugin for SCOM, which is a KQL plugin. I will quickly go through the high-level steps on how I built this custom plugin in the next few slides, but for more information and examples on how to create powerful plugins using KQL to explore your data and discover patterns, you can visit this Microsoft Learning page. So I start with the name of the plugin, then the display name and the description. I then move to the skill group section, and first and foremost, I specify the format or type that I want for this plugin, which is format equals to KQL. Next, I define the skills that I want to invoke from my plugin. As with the two queries that I mentioned in the previous slide, each query will be added into their own skill definition section in the plugin file. Here is what the skill definition structure looks like. Starting with the first query, which can be used to get the most recent security-related detection from SCOM, we can add the KQL query under the template property of the first skill definition section. Then give the skill a name, like get SCOM security detections, or a description and a meaningful name as the display name. You can use the plugin name for direct skill invocation, or you can reference the plugin when you submit a prompt using natural language in the Copilot standalone experience, where it will go through skill selections by the Copilot orchestrator. You can also allow the skill to accept inputs to be passed into a parameter within its embedded KQL query. This can be used during direct skill invocation, but in this instance, inputs are not required. The settings section for the skill is where you tell Copilot where to access the workspace to run the KQL query to gather the information required to take action. Therefore, you not only have to specify the tenant ID, subscription ID, resource group, and workspace name in the settings section for Copilot to find the Sentinel workspace, but you will also need to have permissions to access the workspace via the plugin from the Copilot portal, as mentioned earlier. For the second query, which can be used to get the highest and most recent threat scores from SCOM, similar to the first query, we can add the KQL query under the template property of the second skill definition section. Then give the skill a name, like for example, get SCOM security threat score, or a description and a meaningful name for the display name. Inputs are not required for this instance as well. Again, specify the tenant ID, subscription ID, resource group, and workspace name in the setting section for Copilot to find the Sentinel workspace to run the query for the second skill. Finally, we can save the file with the plugin information and the skill definitions as a YAML file, which is a plugin manifest file. A plugin manifest describes metadata about the plugin and how Copilot can invoke it. With the YAML file saved, we can upload and publish the plugin manifest to Copilot for Security in the standalone portal. As a recommendation, when you are first testing out or tuning the custom plugin, you should add the plugin in private mode first. That is, only you, the publisher, can use the plugin. This is to avoid an incomplete plugin from potentially affecting the prompt experience and results of other Copilot users in the standalone experience. To validate whether the custom plugin for SCOM has been successfully uploaded and published, check whether the plugin has been listed under the custom section and whether it is enabled. Once the plugin is listed in the custom section, the display name and the description should match the display name and description specified in the YAML plugin manifest file. You can also locate the two skills of this custom plugin by clicking on the prompt button on the right of the prompt bar in the standalone portal. The two skills should show up in the system capabilities section if you search for the keyword SCOM, as the word is part of the name and description of both of these skills. And they should match the display name and description specified in the YAML plugin manifest file as well. And with that, I have demonstrated how we can build a solution that consists of a custom Copilot plugin for SCOM that is ready for a proof of concept to show how the plugin can be utilized and how it can add value to an incident investigation scenario with Copilot for Security. And so here are the key takeaways for this session. First, be proactive. Communicate with your security team on how your SCOM implementation is currently monitoring your hybrid environment and what internal insights it can provide on critical applications, services, and servers, and how it can add value to your security incident response and investigation process. And collaborate with your security team or security operations center on developing custom plugins that would leverage the critical monitoring data from your SCOM environment in use cases like security incident investigation, impact analysis, and security reporting. Also, encourage your ISVs and the SCOM product group to build useful and practical APIs or solutions that integrates SCOM with Copilot for Security. So in this session, we saw how custom plugins in Copilot for Security can bridge the gap between on-premise or legacy systems and newer capabilities in generative AI. Custom plugins allow you to build your knowledge into the system and extend Copilot into your workflows and experiences by connecting to your business sources. You can build your own custom plugins for SCOM to perform specialized tasks or enrich your investigation. And the internal knowledge and insights from a healthy SCOM environment can be a valuable source of intel for Copilot in use cases like security incident investigation, prompt enrichment, impact analysis, and security reporting. And finally, Copilot's ability to simplify the complex helps flatten the learning curve for SCOM, resulting in time save, increased productivity, and unlocks new skills for more junior analysts and senior practitioners. I would like to thank you all for attending this session, and I really appreciate your support and encouragement as well. Please enjoy the rest of the sessions in this awesome virtual event. Thank you.